Let's look at the graph of another exponential function where 2 is the base. And now we're going to raise it to a negative x power. So when you have the original equation y equals 2 raised to the negative, and you're going to put in a value for x, it's best to always use parentheses. We haven't been doing that in the past, but it is really important to make sure that you can see what you're putting in as a negative 2, but the problem also had a negative in it. So 2 raised to the negative 2 is the same thing as 2 to the positive 2, which is 4. Now let's put in negative 1 into the original equation. 2 raised to the negative 1, which is 2 raised to the positive 1, which is 2. Putting 0 back into the original equation, 2 raised to the opposite of 0. Well, the opposite of 0 is still 0, and 2 raised to the 0 power is 1. So now if we put in positive 1, 2 raised to the negative positive 1 is 2 raised to the negative 1, which is a negative exponent, which indicates that we have a reciprocal. 1 over 2 to the 1 power, which is 1/2. And putting another number into the original equation, we will have 2 raised to the negative 2 power. And a negative exponent is a reciprocal. It's 1 over 2 squared, but 2 squared is 4. So that's 1/4. So if we wanted to graph these numbers, at negative 2 we were positive 4. At negative 1 we were positive 2. At 0 we were 1. At 1 we're only a half. And at 2 we're down to a fourth. So you can see that this is what we call a decreasing function. As you travel to the right of the graph, your numbers get smaller and smaller. And it's sometimes helpful to go through your points that you found that you're trying to graph. Now again, we need to know how low this graph is going. Will it continue to go down below the x-axis? Well, you're taking the number 2, the positive number 2, and raising it to powers. So is there any way that that positive number would ever turn out to be negative when you're just multiplying it to itself a bunch of times? No. So our asymptote is again here at the x-axis. The way you can find it is look for the number added outside of the exponent, and since nothing's added, we could add 0, which gives us an asymptote y equals 0. What about that domain and range? Domain is left to right, and it goes all the way to the left, and it goes all the way to the right. So our domain, most of the time that you are given a function, will be all real numbers. This is not the case for square roots and for fractions and for the thing we're going to do next, logs. But other than that, all functions given in function notation have domain, all real numbers. Range is how low it goes. Again, it won't quite get to 0, and it goes up and up and up to infinity.